Good afternoon, all of you. So today we are going to discuss regarding second order control system. The problems we will solve depending on second order control system. So here is the question. Consider the unit step response of a unity feedback control system whose open loop transfer function is. The open loop transfer function is given and obtain the rise time, peak time, maximum overshoot and settling time. Okay, this is the question. And we have the solution here. Question number 4. This is question number 4. So this is unity feedback control system. This is open loop gain for unity feedback. After doing unity feedback, g of s by 1 plus g of s into h of s. H of s is 1. So you will get this equation 1 by s square plus s plus 1. So comparing to the standard equation omega n square divided by s square plus 2 zeta omega n s plus omega n square. What is omega n here? Here omega n is natural frequency. So comparing this standard equation with the given equation, omega n square is equal to 1 here. In the numerator here it is 1. So omega n will be 1. And substituting in comparing this 2 zeta omega n equals 1 here. Here it is 2 zeta omega n is equal to 1 here. Now substitute n equals omega n is 1, then you will get zeta as 1 by 2. Since zeta is less than 1, half is less than 1. So underdamped response. For underdamped response, these are the formulae. Okay. Alpha. What is alpha? 180 minus cos inverse zeta. Zeta is half. Half will be. So alpha you will get it as 120 degrees. Okay. Now what is omega d damped frequency? Formula is omega n under root 1 minus zeta square. Upon substituting these values, you will get 0.866. Now you can get rise time. What is rise time? Alpha by omega d. That's why we found alpha here and omega d here. Okay. Substitute here to get uh, rise time. Rise time is 2.417 seconds. In the same way, peak time. The formula for peak time is pi by omega d. Upon substituting here, you will get 3.363 seconds. Now maximum peak overshoot. Okay, the formula for maximum peak overshoot for underdamped is e power minus pi zeta divided by under root 1 minus zeta square. Upon substituting the value of zeta here, you will get 16.3% maximum peak overshoot. Now settling time 4 by zeta omega n. This is the formula for settling time. Upon substituting uh, zeta value and natural frequency, that is omega n, you will get 8 seconds settling time. This is about question number 4. Now coming to question number 5. Here is question number 5. In this, he has given unit step response of a second order system is shown in figure. Here is the figure it is given. This is the response to a step input. Unit step is the input. This is response output. So here is the peak time. You can see 1.2, less than 1.2, and maximum peak overshoot 1.2, and rise time is 1, and delay time is more than 1. Okay, and settling time is almost 9, 8, like this. Okay, this is the graph given for unit step response. You need to find rise time, peak time, maximum peak overshoot, settling time. Just now I said what is the rise time here. Already rise time is given here 1. It's 90%. Okay, 90% of the maximum output, it is rise time. So we'll go to the solutions as per the graph. Question number 5. This is question number 5. So y of t is response, reaches first time to the steady state value, final value is rise time, that is 2.4 seconds. First time, okay? How there is a graph to reach at 1 first time, that is 2.4, as you can see here. This is the output, first time to reach 2.4, okay? Time is here 2.4, you can see here. This is 2.5, this is 2.4. First time it reaches the output, that is rise time. Okay. So coming to the next point, next question. Here is the question number 5, sir. Here is the question number 5. Okay, 2.4 seconds from the graph. Peak time. Okay, when y of t reaches at maximum value, that is 3.6 seconds, as you can see in the graph. It's very clear. And coming to the question number C, bit C, maximum peak overshoot. The formula for maximum peak overshoot is maximum value minus step value divided by maximum value, okay, into 100%. That is 18% maximum peak overshoot. And settling time is 7. From the graph, you can see when it reaches the transient point, that is 7 seconds. This is about question number 5. And coming to question number 6, here the standard equation is given along with maximum peak overshoot and settling time. By using these two values, we will be finding other values such as settling time, omega n value, and that's it. Okay, all the values we will see. Maximum peak overshoot, the formula is here, and zeta is not given. So maximum peak overshoot, substitute here, and by solving you will get zeta as 0.69, that is less than 1. This is also under damped response. Then settling time. Settling time formula is 4 divided by zeta omega n. Upon substitution of settling time is given, substitute here, you will get omega n value as 2.89 radians per second. Now upon what is TS here? Here also settling time. Okay. And coming to question number 7. Here is output response. The transfer function of a second order control system is given as 36 divided by s square plus 2s plus 36. So upon comparing to the standard transfer function, omega n square is 36, so omega n will be 6 radians per second. In the same way, after comparing this to zeta omega n equals 2 here, okay, now you will get zeta as 0.167. It is also under damped response since zeta is less than 1. So settling time you will get upon substitution 4 seconds, and the peak time it is pi by omega d, that is 0.531 seconds, and maximum peak overshoot is 0.58, and the rise time is alpha by omega d. Alpha is 80 minus cos inverse zeta pi by 80. So you will get this as upon substitution of all the values you will get 0.294 seconds. This is about question number 7. Okay, 7 or 8. 7. Now coming to question number 8. Here is question number 8. Here is P controller. Okay, PID controllers. We are going to the PID controllers. P means what? Just add a block KP whose value is given. Okay, and the the transfer function is given as this. So steady state output is given as a steady state output. Limit t implies to infinite x of s input. Okay, and xss, what is input for P controller? S. Kp is S. Upon substitution of this in the place of substitute here this equation along with S, you will get 4 by 9, that is 0.44. This is steady state output, and the error is, you have to find the error, 1 minus our steady state output by 1, that is 0.56%, 56%. In the same way for I controller, just multiply this and multiply this with 1 by S. So you will get this as divided by S. Here you can see it is 1 by S. Okay, so 4 by 4 you will get 1. 1 minus 1 by 1 is 0% error, steady state error. In the same way, D controller, for D it is 4. Okay, KD is given as 4. So substitute in the place of 4S. Okay, 4S. KD is given as 4 and S multiplied by S. And upon substitution of this, you will get 0 here. Okay, and the steady state error is 100% here. This is PID controller, all at the same time. Kp plus KDS plus Ki by S. So all these are equal to 4. Upon substitution of this 4 plus 4S plus 4 by S, you will get some equation here. Upon substitution in the standard equation, you will get 1. That is, steady state error for PID controller is 0%. Okay, so this is a question number 9. This is also same. So question number 9 will be homework for you. How many questions are there in this sheet? Question number 9 is the last. Okay, 9 will be homework for you. Okay, you understand and write in the paper and submit. Thank you.